You should have all received the handout from my substitute. This is Intro to Section 7.3. We're solving systems, except this time you can see that we have 3 equations and 3 variables that we're solving for. So we have the steps written out on the top right-hand side, and we're going to go through that first. All right, here we go. So looking at step 1, it's saying use the x term that has coefficient 1 in the first equation to eliminate x term in the second equation. So you want to focus on those first 2 equations and getting specifically the x terms to cancel. All right, I can look at those and see that the x terms are already opposites, so I don't need to multiply either equation by any sort of number. Instead, I'm just going to take those 2 equations and add them together as is. So when I do that, you can see the x terms cancel. When I add the y terms together, I get 1y. Add the z terms together, 3z. Carry down the equal sign, add the constants together, and I get 5. Now I'm going to move on to the next part of my steps. Now it says use the x term with coefficient 1 in the first equation to eliminate the x term in the third equation. But when I look at these two, if I added them the way they are, the x terms are not going to cancel. I have a 1x and a 2x. I need them to be perfect opposites. So what I want to do is leave the bottom equation alone, so its x term is 2x, and I want to turn the top equation into having a leading term of negative 2x. That means I will multiply the entire first equation by negative 2. Now that you see what that looks like, now I'm going to go ahead and add these equations together, and you'll see the x terms cancel. The y terms will give me negative y. Z terms add to negative 1z. Carry the equals down, and the constants add to negative 1. All right. Now that we've completed the first 2 steps, now we're going to go to the third step. Now it says use the y term of coefficient 1 with the second equation to eliminate the y term in the third equation. Okay, so actually what we're doing is we're using these 2 results that we just came up with. Okay, so you're not actually going back and using the second and third equation in the original matrix. You're actually just using these 2 results that you ended up with from step 1 and step 2. And you're going to use those together and solve them as a system where you want to eliminate the y term. So I just wrote those together. You can see the 2 of them stacked on top of each other. And I would want to get the y terms to cancel. In this case, the y terms are already opposite, so they will cancel when I add these equations together. In this specific example, there's no need for me to multiply either equation by a number. I am just going to add them together the way they are. Let's see what happens. Here we have, all of a sudden, an equation where the only variable left is z. And you take that as a nice result as opposed to what we started off with 3 different equations, 3 different variables. Now we're down to 1 single equation with 1 variable. So let's solve it. If 2z is equal to 4, just divide both sides by 2, and you'll have your solution for z. Now looking at this, you know you're not done because we're trying to solve a system. That means we need to find x, y, and z that will solve all 3 equations perfectly. We have our z. We need to try to get back to finding x and y. And we are going to take our solution for z and substitute that back into one of the equations from step 2. You want to look at those 2 equations that are circled in green, okay, because those are down to just having 2 variables in them, one of which is z. So you just want to pick one of those equations that are circled in green and substitute our solution z equals 2 into that equation so that you can solve for y. So I just happen to choose, that top equation that was circled in green, y plus 3z equals 5. I substituted z equals 2 in for z, and now I end up with y equals negative 1. Okay, we're almost there. We have z, we have y. Now we still need to solve for x. So we need an equation that involves x. So what you want to do then is go back to the beginning of the problem. You actually have 3 different equations in that original problem that incorporated x, y, and z. So I'm just going to choose one of those equations. It doesn't matter which one you use. I'm going to choose the first equation, okay? I will choose the first equation from that original system, and I will substitute in z equals 2 and y equals negative 1 so that I can then solve for x and be done with this problem. So you can see my work here using the top equation, substituting in negative 1 for y, substituting 2 for z, Carefully solving for x and x equals 1. We did it! We found the solution. So I know at the bottom it gives you some interesting steps for what back substitution is. I'll tell you more about back substitution tomorrow. For now, when you're doing these problems, just do the substitution in the manner that you see in these notes. It's always a good idea to go back and check your answers. A lot of times we write our answers down as an ordered triple instead of an ordered pair. So remember to order them specifically X, Y, Z. So when we write our order triple for the solution to this system, the order triple would be 1, comma, -1, comma 2. Okay, to check your answers, don't forget, it's as simple as just subbing those 3 numbers in to the original 3 equations and making sure that the solution set perfectly solves each of these equations and makes for true equations or true statements. All right, that's all. Feel free to go back over this tutorial as many times as you need to and use this as a guideline to complete your problems today where you're solving a system with 3 equations and 3 variables. Good luck.